Great. Good afternoon, everyone. My name is Emily Ping O'Brien. I'm from Worcester Polytechnic Institute, and I'm also a 2021 IMLS Leading Fellow. And I'd also like to introduce the other members of my group, Lencia Beltran from UNC Wilmington, who's also a Leading Fellow, Greg Jansen and Dr. Richard Marciano, who are from the Advanced Information Collaboratory at University of Maryland. Our presentation and associated paper are titled Framework for Unlocking and Linking World War II Japanese American Incarceration Biographical Data. So our research involved using historical records obtained by Dr. Marciano from the National Archives. The majority of the records come from the Tule Lake concentration camp in California. It was one of the 10 concentration camps to imprison Japanese Americans who were forcibly removed from their homes during World War II. And I also wanted to acknowledge that as a group, we recognize the records used in this project were created and provided by the US government, and therefore do not accurately convey the actual lives and experiences of incarcerated Japanese Americans. And our work also seeks to respect the privacy of the individuals and their families. And we approach this time in US history with humility and a willingness to learn. When it comes to our research, we had three main approaches. The first, to address entity resolution. Next, we show techniques using social network analysis. And finally, we apply spatial analysis to our data. So we're hoping this project highlights the transformation of information to knowledge and believe this project could be a model for other narratives of serial forced displacement in America. And now I will pass it over to Greg.
Hey, this is Greg. I'm going to talk about the entity resolution, or the linking of individuals across different records and events. The first data set that we're linking between is the Form 26 data that you've already heard very much about. So I'm actually going to go right past this slide, but this is the intake data when individuals and families were brought to assembly centers or camps. Next slide. And we are linking that data to the final accountability rosters, which is the outtake data when families and individuals left camps. Sometimes due to a transfer to a different camp. So there are sometimes multiple records for each individual in this data set that's also called the FAR, shorthand called the FAR. Next slide. So here's sort of an overview depicting both sets of records. Each is in a data file that has one row per individual, and about 100,000 rows in each data set. The rows describe a person, and we want to know when a person on a row in the FAR is the same person described by a row in the WRA data set. The shared attributes across these data sets are shown here. You have first name, last name, birth year, and family ID. And if we just look at all of this at once, we have something like 16 billion combinations that are possible matches, which is far too much. So next slide, please. We're going to segment the data and only look at possible matches within groups of records. So we segmented the data first by this family ID, and that ID is applied very inconsistently. It's formatted differently, and sometimes just plain missing. So it's not going to get us all the way there, but we can at least subset the records and use this data to solve some of the linking problems. So next slide, please. Within the groups, we score all the possible matches between the individuals or the events recorded in both. So the scoring algorithm involved the first name and the birth year. So a first name was a fuzzy match. So sometimes they're spelled differently by clerks or heard differently by clerks recording the data. And so the name on the FAR may not match exactly, but it's maybe close. So we used fuzzy wuzzy to get a ratio of the match. And then we boosted that with the birth year. The birth year has to match in order for the name to have much weight. And then if the birth year matches all by itself, we give that sort of a lower weight in the score. Next slide, please. So this is a grid of possible matches between the FAR and the WRA dataset. And each possible match is scored, and you can see the weight of that score listed there. Some are 1.0 for a full match, or 0.75 for like a birth year only match, or some combination thereof. With this technique, we were able to march through all these records and match up about 80% of the the FAR records with WRA records. Next slide. To get us a little further, we decided to deal with the family ID issue by circumventing it. We used a soundex or a sound index of the last name. So that compensates for different spellings of the last name. Instead, it's a phoneme index, a sequence of phonemes. And that gave us groups of about 100 individuals. They're not all in the same family per se. They just share a last name or share the way their last name sounds. But so the computation took longer, but still we were able to get a little further. An additional 7% were matched. And then we tested this against some manual matches that Richard had performed on a subset of the data of 204 individuals. And Richard was able to match up, Richard, our gold standard, was able to match up 199 out of those 204 FAR records. And we were able to match up through the algorithm 168 of those records. So there's about a 15% gap between the algorithm and Richard that I don't know if we could ever close. Next slide, please. All right, that's me.
Thank you. So my work and our research involve exploring computational methods to share biographical stories and bring new clarity to events. It also ties in with Dr. Marciano's work on computational biographies, which is mentioned in our paper. Specifically, my work focuses on aspects of prosopography or an investigation of a historical group or of several interconnected groups that's linked by some common factor. And computational prosopography has emerged with social network analysis. So with social network analysis, I'm specifically addressing the field of data analytics that uses networks and graph theory to understand social structures. And this involves extracting data from index card records and applying graph algorithms found within networking tools, specifically NetworkX and Plotly Python libraries. So the data set I used came from part of the WRA record series. They were transcribed incident or index cards that were recorded by government officials regarding events, incidents, including reported crimes that were occurred at Tule Lake concentration camp. And they contain category of the incident accused of, the description, as well as information about the individual involved. And it notes the associated full police record that contains more detail. So as a group, we created a series of public Jupyter notebooks describing our work and includes our Python computations and output. And in my social network analysis notebook, one of my first examples involves creating a data frame from the index card kit data set. And this is a simple node graph that was created with NetworkX. And an event I was particularly interested in was a event that occurred on November 4th, 1943, when a congregation of Japanese Americans in the camp who were dissatisfied, obviously, with the situation, conditions, and lack of supplies, was deemed a riot by government officials. So using the data set and pulling all cards from this riot category and the date, we're able to view all the cards reported that involved individuals who are accused of participating in the riot. So this represents almost 4,000 cards, and the amount of nodes in the graph just demonstrates, the scope of the event and those that were involved. So based on this event, I really wanted to take a closer look at what incidents preceded and what followed the riot, and taking the data set and examining a date range of 5 days before and after November 4th, I created another node graph to display all the event categories from the cards. And particularly, I was interested in a theft event that occurred on November 1st. So using the data frame, I was able to find 9 cards with exact same description from this event. So those that were accused had a description of found picking vegetables for individual use in Western farm area, also away from regular place of employment during working hours. So based on this one event and other similar findings, I had questions regarding this informal gathering of the accused incarcerees and additional or other intentions they may have had beyond what was reported in the cards. So, was this truly a theft? Was it planned? What was discussed beforehand? What was discussed after they were accused? And did this incident, recorded as a crime, lead to some of the incarcerees joining the congregation on November 4th? Another way to verify the number of the cards and events surrounding the riot was use Plotly, Python library, to create, in this case, a bar chart. This is a clear way to view other incidents and how they related to each other and how they relate to each other. For example, there's reports of breach of trust on the day of the riot, which included descriptions of construction tools that were never returned. And there's also records of incarcerees who were jailed in the military stockade following the riot. So finally, in the last example, using Plotly Express, I created an animated bar chart to show all the incident cards by category that recorded at Tule Lake Camp each year, not including the right event, which skews the graph and makes it even harder to read because, again, it's more than about 4,000 cards. So through examination of these results using social network analysis, one can conclude that events such as thefts and other cases breach of trust were clear displays of the rising discontent in the camp regarding access to food and supplies. And as previously mentioned, these index cards also include ID numbers for detailed police reports that we currently do not have. But if we were to go back to the National Archives, we would know exactly which reports to pull to find out more information about each event. And so with social network analysis, we can easily view different interactions between individuals over time and how they relate to various events as reported by government officials, ultimately presenting additional opportunities for analysis and research. And now I'll pass it to Lencia.
Thanks, Emily. So another interest and focus of our research in this paper is to visually understand the movement and spaces of how Japanese Americans lived while incarcerated during World War II. And this approach can be done through spatial analysis. Next slide, please. So to give a brief definition, Dartmouth Library describes spatial analysis as a geographic type of, or a type of geographical analysis which seeks to explain patterns of human behavior and its spatial expression. So essentially, it allows us to answer the where questions and model new information and relationships. So for this specific case study, only 25 names were selected, and their selection was based on how often they appeared in the incident cards as being involved in the uprising at Tule Lake. So I used 3 data sets, which were discussed earlier by both Greg and Emily, to extract the geographic information for all 5 movements, which are the point of origin, assembly center, first incarceration center, relocation to Tule Lake, and the final departure state. So to briefly explain this map, to the right, it's showing these 5 movements for one of the 25 persons. The person originated in Hawaii and then was sent to Sand Island in February 1943, also located in Hawaii. A quick note, but at the time, Sand Island functioned as a detention center and not as an assembly center. And then in September 26, 1943, this person was relocated to Jerome, which was their first incarceration center. And then 4 days later, they were sent to Tule Lake. And then in 1945, it's recorded their last departure state was there in California. Next slide, please. So for this map, I wanted to visually understand the concentration of individuals at each location for all 5 movements. To do this, I created a column that included the total number of individuals. And if you hover over each location in the Jupyter Notebook, you can see the total size. This is not pictured here because of limitations. Next slide, please. So the map here is on the top right is an alternative approach for using interactive maps to show movements. So this was created using Folium. Folium uses layers, which allows users to select or deselect what is visible if they want to see specific information. And what's also neat is that Folium has a feature that allows for GeoJSON and shapefiles to be added as layers, which can be seen in the map as a drop-down list. So there's a lot going on this map, but essentially it's showing all 5 movements for 25 individuals. And then the blue shape files are represent the evacuation orders specific for the 25 selected individuals. The movements are recorded as enumerations on the circles. And then also when you hover over these circles, you will get a pop-up of the person's name. Also shown here, also shown here on the left is just a snippet of the code that I used to filter the data to find the locations for each person. Next slide, please. So without really going into detail here, this map is just another perspective of how to look at where individuals were relocated during movements. Next slide, please. So in conclusion, these 2 analytical approaches required an investigation of individual records, but with a unified registry of individual data, we can then apply the same methods to a larger group, which will allow us to have an even more comprehensive and complete picture of events. Also, we created and published individual Jupyter notebooks, as Emily mentioned, that go more in depth on the approaches that we discussed here during this talk. These notebooks are available and can be found on the Advanced Information Collaboratory Cases webpage at the following URL. This reaffirms the framework that we hope others can use or reference in their research using historical records, especially those regarding serial forced displacement. And for folks who are interested, the notebooks are open, and we certainly welcome any feedback on approaches or techniques you may have. I also want to give a special thanks to Jeff at Densho for his support and feedback, and wish to acknowledge the support of the IMLS Drexel University Leading Project. With that said, we're happy to take any questions.